In this video, we are going to study a couple of ways to make this molecule from the starting material here. So let's first review a little bit of a nomenclature. So this compound is an alcohol, and we're studying alcohol reactions. So here, if you to name the compound, so 1, 2, 3. So this compound is 2-phenyl 2-propanol. And this is still 1, 2, 3, but this is now propane, and we're going to say 2-bromo 2-phenyl propane. Okay. Now let's design a couple of ways of doing synthesis. If we see the alcohol, that's a tertiary alcohol. We cannot think ever on an SN2 reaction that is to sterically hinder substrate. So we need to plan an SN1 to do that reaction. So because we will have a stable carbocation, but how do I make that? Because we know that OH is a very bad leaving group. So our first step here should be transforming that into a good leaving group. So one way of doing that, we could use, say, under acidic conditions, you could simply protonate the OH, and that way you will get a good leaving group. You will have water. And this will report, and you will form a stable carbocation. And let me see. This carbocation, notice, is tertiary and also is next to a benzyl group. So it is great. It's like benzylic and tertiary. All right, so very stable. After that, you can add, for example, KBr in water, and that will give you that. Other ways of doing things in this direction is instead of using acid, or you could use here, say, HBr. So in but it's not as efficient as doing, for example, strong acid, creating that, and then adding KBr. But you could do that, protonate, get a good leaving group, and then you will have the bromide to do the nucleophilic attack. Here you have K plus negative, so you will have your nucleophilic attack over here. And if you use KBr, your nucleophile, HBr, your nucleophile is also going to be KBr. Other ways of making OH a good leaving group is transforming that with using tosyl chloride. So here I'm going to write an alternative path to make OH a good leaving group. If you use tosyl chloride, pyridine, you will create the following, and I'm writing that here below. Here you have OTS. Tosyl chloride. Okay, and that is an excellent leaving group. It will depart, and you will form the carbocation here, and then you treat it with KBr here, say from here to here. We treat that with KBr. So different ways of doing that. You can, with acidic conditions, transform that into water, a leaving group. You can make it tosylate and make it react with KBr, those ways. So that involves, again, changing the leaving group from OH to something that's better leaving group, and then a substitution reaction. Now, another way of doing that would be, for example, doing an elimination reaction via E1. And if I do that, let me do that pathway. Let's see, I'm going to draw now an arrow over here, because I am considering different paths to make the same compound. So what I'm doing here now is I'm going to say that I have concentrated sulfuric acid. What that does it goes through a carbocation intermediate, that's E1, but under those conditions, we will form the alkene. So after you form the carbocation in that pathway, we will, by drawing, we will make this. So this is the E1 product, the alkene, and this is the CS and 1 product. Now, once you have that alkene, here you can use a different reagent to get here. Notice that you can use now HBr, so hydrobromic acid, and Markovnikov path reduced selectivity, meaning that H is going to be added here at the least substituted carbon, and then bromine here. Remember that we know that that happens that way because you will get the more stable carbocation. So here, this is Markovnikov, and that way you will get the same alkyl halide. So again, there's more than one way of doing things. Here we have started with an alcohol. If you want to do a substitution reaction, the first thing to notice here is that we need to make OH a better leaving group, and you have a couple of strategies. Acidifying in that leaving group would be water, or reacting with tosyl chloride to make this a tosylate, also an excellent leaving group. Either way, you're going to get an intermediate, which is a carbocation, that will undergo an SN1 reaction to give you the final product. And another way of doing things was them making an elimination reaction. So tertiary alcohols, when treated with concentrated sulfuric acid, will undergo elimination. So this is actually a dehydration. And you will form this as your alkene, and then treat it, do an addition reaction with HBr, and it will give you the Markovnikov reduced selectivity, so H at the least substituted, bromine at the more substituted to get the desired product.